Okay, let's look at our first example, example 1 of area 8 in our problem solving and data analysis. And this area deals with uh, result generalization. In essence, how do you take a sample uh, from a population, and then when you finish, you generalize the results. We call it results generalization. So this particular problem is looking at a square field that measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. So this is our square field, which is 10 meters by 10 meters. Each region is, and you have 10 students who are going to do a survey in this area. Each region is square and has side length of 1 meter by 1 meter. All right, so you have 10 students. That's going to take a square. So we're going to take one little square here. We're going to take one little square here. We're going to take one little square here, something like that. We're going to take 10 of them, and each of them is 1 meter by 1 meter, and 10 of them. And no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown. So in essence, instead of me trying to dig the entire area here to 5 centimeters and determine the earthworms in this area, I'm trying to take a sample here. So I'm taking a sample. So I have 10 samples. And each sample is from 1 meter by 1 meter. That is 1 meter squared area. So if I have 10 of them, then I have 10 meter square area to find earthworms. Now, as you can see, this is A, this is B, this is C, all the way up to J. And then A gives me 107, C gives me 146, and J gives me 166. The question here is, based on the data I collect here, how many earthworms can I estimate to be in the whole region here? How many of them? So this is what we call a result generalization. So I'm going to take a sample here. I'm going to take a sample here. I'm going to take a sample here. So how do I generalize my results? Well, the best thing to do is to find the total number of earthworms that I get across all the samples. So in essence, I will sum all these numbers, and that will be 107 plus 147 plus 146 all the way up to 166. When you sum them, you get 1471 earthworms. This is how many earthworms you get for this area. Now the question is, if I'm getting 10 for a 10 meter square area, I'm getting 1471. Remember, this is 10 meter square because it's coming from all the 10 small 1 meter square regions. Then, if I have a 100 meter square area, which is 10 by 10, because the entire area here is 10 by 10, what would that number be? And so by simple proportion and by ratio, you see that my x over 100 is equal to 1471 over 10. So for me to find x, then x is equal to 1471 times 100 divided by 10, and that gives me about 14710. Right? So in essence, I get close to about 15,000, an estimate of 15,000 that will occupy all the total area of interest. And therefore, the closest answer here in this case is C. This is how you take a small sample, do a survey, and use proportion to generalize what your results will be. So your answer in this particular case will be the answer shown.